Now, today we are looking at variation. Everybody say variation.
Variation.
Again.
Variation.
Now, what is variation? We say variation is a relationship between two or more variables or quantities. Is that okay?
Yes.
Variation is a relationship between two or more variables or quantities. Is that okay?
Yes.
And now, there are key words that we mentioned there. There is relationship, there is variables or quantities. So what is relationship? What is relationship? I believe some of you must have known what a relationship is. In your own term or in your own way, what do you understand by relationship? Who can you help us? Relationship. Who can help us? Is there anybody that will say something about relationship? Relationship. Nobody? Yes.
Relationship is someone you love mostly.
Okay. When someone loves another person and the person loving the person back, it's also said to be a relationship. So that means there could be a relationship between a boy and a girl, or a boy to a boy. Is that okay? Or a girl to a girl. It's a relationship. There's also a relationship between husband and wife. Is that okay?
Yes.
That relationship is called marriage. Is that also?
Yes.
And you know, in this our environment here, we found ginger. And we can see that there's a relationship between ginger and fertilizer. Is that okay?
Yes.
So when we mention two or more variables, that two or more variables, we are referring to the variables could be two and it could be more. Is that okay? But today we want to look at the one that is only two variables. So and the two variables, we call it a direct variation. The one that involves two variables, we call it direct. Is that okay?
Yes.
So you just write this as we have defined. So we say variation. So we are doing one or A definition of variation. So variation is a relationship between two or more variables or quantities. So variation is a relationship between two or more variables or quantities. So as if we have explained relationship, let's explain variables. Variable is things that changes, and in mathematics, things that changes, we use alphabet for them. We use alphabet. So variables is said to be alphabet. Is that okay? It's A, B, C, Z. They are variables, and this alphabet can take numbers. Is that okay? When you say A is equals to 5, that means the value of A is 5. Is that okay? So when you have found that A to be equals to 5, you can say that is the solution of that problem. So if A is equals to 5, A is said to be the solution of that problem. Is that okay?
Yes, sir.
Yes. So we are saying that if my A is equals to 5, we are saying now that means anywhere I see A, I can put 5. Is that okay? Anywhere I see A, I can put 5. That means 5, A is no longer unknown. A is no longer, it's only unknown if you don't know that it's 5. Is that okay? So, and that is variable. And variable also is something as quantities. Because when you say ginger is your A, and you say fertilizer or ginger start with G, you can say ginger is G, then fertilizer is F. So you can say G, you can say like this, G varies directly as F. You know, that's the language that we're going to do today. Is that okay? So we're looking at variable. So variable is something as quantity. Quantity in most cases is like the weight of something, and that weight is in numbers. Is that okay? So like if I want to measure ginger now, it will be in gram or in kilogram. I want to measure fertilizer, it will be in gram or kilogram. Is that okay? Yes. So any question on definition of variation? Any question? Now let's look at B. B, which is types of variation. Types of variation. Types of variation. We have one. We have direct variation. Two, we have inverse variation. And three, we have joint variation or combined joint variation. Then we have the fourth one, which is partial variation. Fourth one is partial variation. So let's start. In other subsequent class, we're going to be looking at the rest. Or let's look at one, which is direct variation. Direct variation. So direct variation, we said, is limited to only two variables. Is that okay? It's limited to only two variables. Let's look at this diagram here. If you look at this diagram here, X varies directly as Y. You say it. Say X varies directly as Y.
X varies directly as Y.
So when you have this kind of structure, it is called a direct variation. Is that okay? Yes. It's called, this is an example of a direct variation. So, but in solving, what we want to work it out, we must introduce what we call the constant, the K. K is an alphabet that is being commonly used, but K can be any alphabet, but mostly K is used. So for you to introduce that K, which is the constant, you must substitute this symbol, this varies or proportionality symbol. So when you remove this one, then you're going to put X equals to and K. Is that okay?
Yes.
Yes. So this is it. You have this X is equals to K, Y. But what we are saying is that this is a direct variation. And when you divide both sides by Y, you can find what is K. K will give you X all over Y. Is that okay? Well, let explain. What do we mean by direct variation? We mean by direct variation simply means that if this value of Y is increasing, just like when we say ginger and fertilizer, if this Y is our ginger, if ginger is increasing, fertilizer will also be increasing. Is that okay? So that relationship is a direct relationship, or is a direct variation. Is that clear? If ginger is decreasing, fertilizer will also be decreasing. So it's either ginger and fertilizer are increasing, or ginger and fertilizer are decreasing. Is that okay? So that is an example of a direct variation. And we said to remove, we always remove this relationship symbol, which is the proportionality sign. Then we introduce our equal